Hello, now we're going to start to explore and literally just explore adding fractions with different denominators, and this is where we usually have some form of trouble, but again I think to see it visually first is the first step. So we're going to have a go at adding, okay, I'll write down here, half, add, oops, a third. Okay, and there we are, add 1/3. And what does that equal? Well, because we have different denominators, we have to find a common denominator of 2 and 3. Now, children are often told, just times the 2 by the 3 and 3 by the 2 and you'll get 6. Which, yes, it does work, but why? And it's linking it back to those equivalent fractions and the times tables. So first of all, I would find my equivalents to do with a half, okay, and explore it. So there we are. There's 1/2, which also equals. So I go back, and I find it is also equivalent to 2 quarters, which is also, I use another acetate, which is timesing by 3, is equivalent to 3. 1, 2, 3, 4, 5, 6. And I may want to just explore a little bit more and do the next equivalent fraction, which is 4/8. Okay, well, I think I've done a few of those. Okay, we can leave it and move on to the third and do the same. So 1/3 and an equivalent fraction. Oh, hang on a second. Using the patterns of the times tables is 2 out of the 6. And if I know it, I know this is the 1 times tables, this is the 3 times tables. Okay, so I'd go up. I'd do one more maybe, because I'm just exploring, that's all we're doing, is exploring. 103 and times it by 3, which is 3 out of, oh my goodness, sorry, you can't see that, 3 out of the 9. Once I've done that, I look back. Now, which of my equivalent fractions has the same denominator? This one and this one. This now allows me to add, okay? So really what I'm doing now is I'm adding 3, 6, 2, 2, 6, on adding these two together. Now what's quite nice about this is I can go back and I can physically, I've times this by 1, 2, 3. So I take my 3 and I pop it over there and I've got 3, 6. Okay. Here I am timesing my fraction by 1, 2. So I pop the 2 over. Now as such I have my equivalent pieces. I've got, with the wholes the same, I've got 1, 2, 3 out of the 6 pieces, and I've got 1, 2 out of the 6 pieces. Now, if I wanted to, I can physically just add these 1, 2, 3, 4, 5. Okay, so I know I've got 5. Okay, out of the 6 pieces. Does that, I hope that helps. I don't know if it helps or not altogether. Okay, so basically it's just another way of showing that this is what I've got all together. Okay, and it's another way of exploring. So I've got 3 out of the 6 pieces, I have 2 out of the 6 pieces, but if I've got that amount, how many pieces? I've got 1, 2, 3, 4, 5. 5 pieces. Okay, I don't know. Have a think about that one. It may be useful, it may not, because we do look a different shape. That's the only problem I would say. But again, it's just exploring. It may help, it may not. Okay, thank you. Oops, amazing.